Hi everyone, welcome to my channel and welcome to another video. In my last videos, I discussed a lot about the file system, the Linux file system, what is file descriptor, what is file description. So in this video, once again, I want to discuss some very interesting feature about the Linux socket API. And I want to start this video with a very basic question. Can two applications or can more than two applications be, or rather can more than two processes listen on the same IP and port combination on a given Linux machine? So the primary requirement of a process running as a server program is IP and a port, right? So it needs an IP and a port, and usually what we have learned is that IP port combination should be unique on a given machine for the server to listen without any issue on that particular IP port combination, right? So the purpose of the IP is to uniquely identify a machine on a network, and the purpose of the port is to uniquely identify a process or a server application. But the question that I am now putting forward is, can two different server programs listen on the same IP and port on a given machine? For example, both the programs listening on 127.0.0.1 colon 8080 or 0.0.0.0 colon 5555, right? If a process listens on 0.0.0.0, basically it's listening on all the IP, right? So even in such a case, can two different, or let's say multiple different server program listen on the same port when the IP is 0.0.0.0, right? So this is what we will try to see in this video. So this again will lead us to a very interesting feature of the Linux socket API, which has very practical and important implications. So as always, without further delay, let's get started. Okay, so here I have a very simple server program, basically a echo server. Like if you send anything to it, it will just return you the same whatever you have sent to it. A classic TCP echo server, right? So it will be using the TCP protocol. But this holds true for UDP protocol as well, because even for UDP socket, it needs to listen on a IP and port, right? It's not connected. UDP sockets are not connected, but it does need to listen on a particular IP and port for clients to send requests to it, right? So all this program does is that it creates a socket address. It binds itself to IDDR any, that is, it will listen on all the IPs, right? So at least while we create the constraint of same IP, same port, we don't have to think about the IP, because we know that if any other program in this machine listens on the same port, by default we know it's a IP port conflict, because both the programs, like if we use IDDR any, it means that the program will anyways be listening on all the IPs. So a port conflict would mean that IP comma port is basically being conflicted, right? All it does is it first sets up the address, and then it binds to that address, right? And it starts listening. And once it has started listening, once it is in the socket is in listen mode, it will go into an infinite loop. It will start accepting connections, and then for any connection it will simply keep on looping, and it will keep reading from the accepted client socket. If it gets something, it will write the same thing back to the client socket. If it gets anything whose size is less than equal to 0, it will simply consider that the client has closed connection, and it will close the client socket, right? As simple as that. Now what we will try to do is we will try to spawn two instances of this program, right? We won't change the port or anything, but we will simply try to spawn two instances of this program and see how it behaves, right? So let me quickly divide my terminal in two, and let me zoom here as well. So first thing first, I'll compile the code. I have already compiled a while back, but I'll compile it once again. It got compiled, and now I'll simply start the server. It says it's waiting for client, so I'll use netcat, and netcat by default uses TCP connection. I'm connecting on localhost. Remember, we are listening on all the IPs. Basically the server program is now bound to all the IPs, and it's bound to port 55555 on all the IPs of the machine. And so let's try to connect on port 55555. It got connected. It works fine, and so I'm going to run another instance of the same server program in a different terminal. And there you go. It says address already in use. So which means since already a server program is bound to 127.0.0.1 colon 55555, a new instance cannot bind to the same IP port, right? Again, as we are using IDDR any or 0.0.0.0.0, IP is irrelevant here. pretty much the first program is listening on all the IPs. But what this essentially means is that since the first instance is already listening on port 55555, the second program cannot listen on the same address or same IP port combination. That is, for example, localhost colon 55555. So what it means is that since the first instance of the server program is already listening on port 55555, the second instance failed to start because it cannot listen on the same port, and as a result of which it failed to start. So does it mean that multiple processes, or rather I should say multiple server sockets, cannot listen on the same IP and port combination on a given machine? Is that the case? So turns out that's not the case. The Linux socket API does provide you with a flag, or rather a socket option, which allows multiple sockets to attach to the same IP port combination, right? But however, when you attach multiple sockets to the same IP port combination, how you would expect the packets and the sockets to behave might be different from what you will actually get to see, right? So we'll come to that. One such option which allows the Linux kernel to allow multiple sockets to join to the same IP port is SOD port, right? How this flag works is that the first socket that connects to a particular, or rather that binds or attaches itself to an IP port combination should have this socket option enabled, which is SOD port. Right, and once the first socket that joins to that IP port combination has got this option enabled, any future sockets, any future upcoming sockets that also have this particular SOD port option enabled, they can join to the same IP port. Doesn't matter how many sockets are joining in future to that same IP port combination, as long as the first ever socket joining to that IP port combination has got the SOD port enabled, and the subsequent sockets also have this option enabled, they will be able to join the same IP port combination, right? So let's see what happens and how the traffic, or how the packets behave when, or rather how the connections behave when multiple sockets listen and bind themselves on the same IP port, right? What we'll do is that we'll start multiple server programs on the same IP and port, and then we will start multiple client programs that will send echo packets to, or rather so which will send requests to the same IP port. From the perspective of the client, there is just one server, right? The client doesn't know how many servers or how many sockets are listening, or how many server sockets are listening to the IP and port combination. For the client's perspective, it's just one server program. So what we'll do is we'll create multiple clients and let them all of them send data together to the IP port combination, and we will see how the connections behave and how the server programs behave in this scenario. So let's enable this option, and enabling that option is pretty easy, just like any other socket option. So what we are going to do is we are going to create a variable called socket, and just before we bind the socket to the IP and port, to the address, what we are going to do is we are going to set this socket option using set socket. So it's sockft SOL socket SOD use port. So SOD use port, and then the option value, which is 1. Then we will get the size of the socket, and we'll just check that if it's less than 0, we will fail, saying failed calling set socket. And do not worry about this red line. SOD use port does exist, and for some reason the editor or my IDE VS Code is not able to resolve it, but we'll just leave it like that. Shouldn't be a problem. And yeah, that's it, pretty much. That's it. Now we have set the SOD use port socket option on this socket. So now let's recompile it. Once again, I'll divide my terminal into 2. Soon I'll be dividing into more, because I'll be spawning more than 2 servers, right? And now I will compile the program, and it compiled. Now if I start the server, like it's waiting for clients, and so moment of truth, and let's start another instance of the server, and I have not changed, I have not done anything, I have not edited the program again, which means it will still try to bind to itself to all the IPs and the same port, which is 55555. So there will be an IP port conflict on all the IPs on the machine, right? Because it's binding to all the IPs and it's binding to the same port as well. And it worked perfectly fine, like it didn't complain that address is already in use, which means using this SOR use port option, we are actually being able to reuse the port, right? Now let's say had I removed this option and then try to compile, and run it, it won't be able to do so because I have removed the option, right? And so let me just quickly uncomment, and now let's say I remove it now and I compile it, and I'm waiting for clients, and now if the second socket has this option enabled and I recompile it, it won't be able to once again join or connect to listen on the same IP port combination, because the first socket that connected itself, or that the first socket that bound itself to the IP port combination did not use SOR use port, right? So it doesn't matter if the subsequent client or the subsequent server has this option enabled, even then the kernel won't allow it to join the same IP port combination. This is done because of security purpose. The kernel doesn't want any rogue server program to hijack a port and get data out of that IP port combination. Well, let me just recompile it once again. So now what we are interested in checking is that in this case, if I have multiple servers running on the same IP port, and I create multiple clients, if I try to connect multiple clients to the same IP and port, what happens to the connections? Will all the connections land up on one server and the other server program will get nothing, or will the data get copied to both the server programs, or would it round robin? Like, how would it work out, right? The reason I mentioned connections is because since I am using TCP, and TCP is a connection oriented and connected socket type, if once a connection is established with a particular server program, it's very evident that server program will get all the packets, right? So what I'm more interested in here is if I use multiple clients to create single off connections to the IP and port, which server program will the connection land up in, right? So because we know once the connection is established with a program, the connection will keep on happening with that program. So I want to know from a connection point of view, where all does the new connections land up, on which server programs, when there are multiple servers listening on the same IP and port. Okay, so for that, what I'm going to do is, here I have a very simple client script which uses netcat, and what I'm doing here is I'm running a loop from 1 to 100, so it keeps going on for some time. Then what I'm doing is I'm simply sending an echo packet, right? Like a random packet which simply says prefix, whatever. I can set whatever prefix I want so that I can distinguish the different clients, since I will be running multiple clients as well. It uses this prefix and it simply says echo and then this index of the loop, right? And I send it to localhost 55555, and I immediately close the connection. I do not keep the connection open. I immediately close the connection so that every time inside the loop it spawns a new connection to the IP and port combination, and that will help me know where the connection is landing, so which server program the connection is getting established to. And I'll be spawning multiple such clients, so that will actually help us determine which client is sending which connection, and we'll be able to differentiate between the connections from the same client using this index number of the loop, right? Okay, so what I'm going to do now is I'm going to once again split this into another terminal, and I will have to zoom out a bit or else things won't be visible properly. So I'll just try to zoom in a bit, and so let's see how it looks, if it's all visible and everything. So let me start the server here. I'm going to start a single client, Okay, so it's YT, R port, SRC. Okay, so yeah, so this simply, it says could not read probable connect client close, because after sending every packet it simply closes the connection, that's why. But my point of interest is the connection numbers. So each of this echo message is a single independent connection, because I'm closing the connection after that, and this is all I'm interested in, right? So I guess it's fine. I guess I will just zoom it out a little bit. I will also divide this into 3 parts. And now what I'm going to do is I'm going to start 2 server instances. So waiting for clients, and this is also waiting for clients. And I'll make some space here. Okay. So now I'll start one client and let's see what happens. Look at that. So what's pretty much happening is the connections are getting round robin and balanced between both the server programs. The kernel is not bombarding one server program with all the requests, but it's nicely load balancing them between both the server programs. So what's pretty much happening is kernel is providing you with out of the box load balancing between the 2 server programs in round robin fashion, which is so cool. Like you are getting a sort of load balancer, traffic balancer out of the box just by using a kernel socket API feature, which is SODU support. And this is so cool. No fancy external software. It's just native Linux APIs that's in play, right? And now if I just add another server, what do you think will happen? Will it automatically start getting new connections? Let's see. So it will happen for 30 more requests, I guess. I start another one. It seamlessly joined this, so-called tiny existing cluster of 2 programs, and now you have a third program which has joined this cluster, and once again it's seemingly getting all the requests, and you can see that there is no connection drop. Like if each and every connection is landing on one of the 3 servers, and that is so cool. Like I just made a server seamlessly join this tiny cluster. So what I'm going to do now is I'm once again going to start this program with three servers online, right? And once again I'm going to start this, and you can see once again the requests are getting load balanced between the 3 servers. See, more or less it's a pretty equal distribution. Like all the 3 servers, it might not be exact alternate, like, or exact server 1, server 2, server 3, again server 1, server 2, server 3, but it's almost equally distributed, like among the 3 servers. And now what happens if I simply remove a server from the cluster? Let's say I remove this one, the server 2. So you see there is no traffic drop. The kernel detects that one server is no more up, and it's the other 2 servers are still getting the requests, and the sequence is still maintained. If I just remove this as well, now all traffic, the entire traffic is now going to this server. So and see, 57, 57, 58, 58. And there we have a load balancing feature right out of the box from the kernel, which takes care of everything, like a process getting added to the cluster, a process. So when I say server, I mean a server program or a server process, because everything is happening in the same machine, right? It's not like the load balancing is not happening among different physical servers, but in the same server among physical processes. And the fact that the kernel is able to load balance the incoming data among multiple processes inside the same server has got huge implications if you think about it, right? And all of this is happening out of the box with just one socket option on the server socket, right? Okay, so now that we have seen the capability of this SODU support and how it makes the socket behave and how it allows multiple sockets to bind to the same IP and port, what are the implications of it, right? Why and where we would use this feature? So one thing that immediately comes to our mind, and which I just now mentioned, that it gives out of the box load balancing capabilities to the Linux kernel, right? So it lets you load balance incoming traffic or incoming connections among multiple different processes. So think about a scenario where you are using a main process and worker model, right? Pretty similar to some sort of a web server where the main process forks multiple child processes, and it's the responsibility of the child process to accept connections and process connections and generate response. So in such a case, you can easily reuse this feature, and in fact there are web servers and server-side programs which use this method to increase their throughput. So what happens is that the main process spawns multiple child processes who actually process the request, and what the child processes would do is they would create individual sockets, right? They would listen on the same IPN port. Like that way, like the client, for the client it's just the server's IPN port, like a single designated IPN port. So they would connect to the same IPN port. Multiple clients can connect to the same IPN port, and they can send their packets, and they would get load balanced between the multiple worker processes, and each worker process can be scheduled on a different CPU core, right? So this is one of the most common use case that you can think that comes out of the box with this feature. The other advantage that you get out of this feature is something called hitless reload, right, or hot reloads. What happens in a hot reload? Let's say you have a version of a server program running, right, and now you need to update, like deploy a new version of that server with some new feature, right? One very usual process to do that would be you create a new server, deploy your application on that server, you attach that server to the load balancer, and you remove the existing server from the load balancer. This is a very sophisticated process that would need infrastructure support. Like you would be spawning an extra server, and then that would get attached to the load balancer, and the load balancer will see that the new server is healthy. It will also start distributing traffic to that server, and then you put down the old server. It's pretty much like your AB deployment or your blue-green deployment, right? It's very common in Kubernetes world as well, where the rolling deployment happens for pods. But what if, just imagine, what if like a server program is running on your existing server, right, and you want to deploy a new version of the server, keeping the same server, like without taking down the server. You want to deploy a new version of your server program. Like how would you do it? One thing you can shut down the server, replace the binary, and start the new binary, right? In that case, there would be some loss of traffic, because you are restarting the server, and restart would usually mean that the process will be killed and a new process will be spawned. So there is a perfect scenario where you can use this feature of SODU support such that at no point of time the process dies, right? Or if I put it in a different way, at all point of time there will be some process listening to the IPN port combination, and it will be serving traffic, right? So how can you do it? You can pretty much like make your server program listen on the IPN port using the SODU port option, and then when you rsync or put the new version of the binary on your server, you simply start another server process using the new binary, using the SODU port option, and it attaches to the same port and IP combination. Now both your old server version and new server program version, both of them are receiving traffic, and they are getting load balanced, and now you simply take down the old process, right? So your physical server is always up, it's the same server, and you are just swapping the process in a way that none of the server hits, none of the traffic hits are failing, right? Because at every point of time there is a process that's that is listening on the IPN port combination. So let's see this in practice, and how this would look like in practice in using an actual server program. So this is my current version of the server which we just now saw, and now what I'm going to do is let me just once again I will split it vertically as well, and here also I will enter into this cd. Oh, I'm already in that directory. I'm going to make a copy of this server.c program to server v2.c, right? Okay, and in server2.c what I'm going to do is I'm going to make a very tiny change. I'll create a new buffer called buff v2. I'll give it a static size of 10, and I will just put something like v2, and I'll give a \n. And now what I'm going to do is whatever I'm getting from the client side in buff, which I'm storing in buff, I'm simply going to do a concatenation. I'm going to concat with this buff this string called buff v2, right? So all it will do is add v2 with the incoming string followed by a \n, so that on client side the cursor goes to the next line. And not to forget, I will just also increase the size by 3, so that we need to account for the size increase, because it's 3 character v2 and \n. Okay, and yeah, that's the change that we are going to do. That's our server version 2. Very nice, but it solves the purpose of allowing me to explain what I want to explain, right? What I'm going to do is I'm going to compile it, right? I'll just also compile old server once, just in case, right? And now what I'm going to do is, let me start my old server first. So it's waiting for clients, and I'm going to use that the client.sh script, and it has started, right? Now it's the old server is getting hits. So now let's say it's deployed in production. Let's just imagine. And now what I want to do is I want to deploy server v2 on production without taking down the server and without losing a single traffic, right? Without losing a single connection or a single packet. So what I'm going to do is I'm going to simply, let's say, imagine this is my server and I've already uploaded server version 2. In this scenario, I'm going to start server v2 as well. And look at that. Now once again, as usual, the connections are getting load balanced. Whatever is going to my old client, that's just simply returning the old normal echo message, and whatever is going to my new server, that's giving me, for example, for echo packet 58, it returned me 58 v2 because it landed up on the second server version 2. Now what I'll simply do is I'll get rid of my old process because it's upgraded, right? I no more need the old server program, so I just close it. And now all my traffic is going to the new upgraded version of the server, which is server version 2. And there you have it. I just did a hitless upgrade of the server program, of the deployed server program, without losing a single traffic, and it all worked very smooth, right? That's complete 100 requests, 100 connections, and everything worked properly, and I was able to perform a hitless reload without any issue, right? So that's one of the very big advantage of this process, and it's actually used in real world scenario. And there are actual load balancing softwares and server softwares out there which use this methodology to perform hitless reloads without letting the user know that the server program or the server side software is being upgraded without any loss of traffic, right? So yeah, this is what I wanted to discuss in this video. The amount of flexibility the Socket API provides, the features, the huge amount of the treasure of features it provides just out of the box. So yeah, that's it, I believe, for this video. Let me know if you have ever used this option and how you have used it in your case. And so yeah, that's it for this video, and hope you all enjoyed this video, and thanks a lot for watching. See you all soon.